Welcome to this video on creating an algorithmic composition in Opusmodus. Today, we'll be diving into the code behind a generative composition script for short study for string quartet. This script uses randomization, noise generation, tempo-related dynamics, and various other algorithmic techniques to produce a unique musical piece. Whether you're new to Opusmodus or seasoned user, this tutorial will provide you with a deeper understanding of how to create dynamic and complex composition with Opusmodus. We begin by setting up the environment for our composition. The gseed variable is the initial seed for the random number generator, which ensures that the composition is reproducible. By calling initSeed with this seed, we initialize the random number generator. The nbiter variable defines the number of iterations or sections our composition will have. Next, we generate a list of random seeds using the randomN random number function, which will be used to initialize the random generator for each section of our composition. This ensures that each section has its unique randomness while being reproducible. Now we enter the core of our composition script, a loop that iterates over each seed in the seed list. For each seed, the random generator is reinitialized and a series of operations are performed to create a section of the composition. Each iteration's result is collected into the sec for sequence variable, which will hold all the section. Within each loop iteration, we first define the tempo for the section, tempo min and tempo max, set the range for the tempo, and random number select a random tempo within this range. The size variable determines the number of bars in the section, also chosen randomly between 4 and 8. We then generate the pitch material using a variety of noise types selected randomly. The genNoise function creates a noise vector, which is then converted into pitch within the range of G3 to G6, and then transposed randomly. 4 melodic lines are generated using the pitch material created earlier. Each line is a sample of the pitch material, flattened into a sequence. These lines will form the basis of the melodies in each section. To add dynamic variation, we process the density of each melodic line using a smoothing factor. This factor, chosen randomly, determines how smooth or abrupt the change in density are throughout the section. We then map the generated density to velocity, creating dynamic variation in the melodies also related to the tempo of the current section. Articulations are added using a predefined map, assigning different articulation based on the rhythm length or with a default value ordinario if no match is found. That's the mapping and the mapping process. After generating the melodic lines for each section, they are assembled into sequence for each instrument in our string quartet: 2 violins, a viola, and a cello. The final output is a fully formed string quartet composition, complete with dynamic articulation and tempo variation. Finally, we output the score using the def_score function. This defines the structure of the score, assigns the generated sequence to the respective instrument, and apply additional parameters like velocity remapping and MIDI setting. The result is a complete algorithmically generated score ready for playback. Let's evaluate that score. Once this is done, it is possible to refine that score um, just by evaluate and p-print the result of each instrument, something like that, and copy and paste in another document, like that one. So it's totally possible to redo the editing of a score to get a new score, but manually edited, something like that, with more refined things. And I change the end, for example, here, and many things. So, and once it is done, you can export to your favorite score editor as music XML. In my case, I export to Lilypond as music XML and import into Lilypond. So after that, it's absolutely possible to edit the score to finally get a final score with all the parts and all the things you need. The good things when you use Lilypond is if I generate a new version of this string quartet, in my Lilypond file, my parts are only variable, but the page formatting is fixed already. So I can change just the notes, just the part for violin, for all the instrument. But when I compile again my Lilypond file, I will still have get a perfect page formatting because nothing will move. That's the biggest advantage to use Lilypond in that case and in case of algorithmic music composition. That's all for today. See you soon. Bye.